Hello students and friends, welcome to my YouTube channels. So today my topic is heat transfer. So heat transfer introductions part I will cover today, and I will discuss concept of the mode of heat transfer, conduction, convection, radiation, and for plane wall how to minimize, how to develop the formula and how to solve the problem, that about we will discuss today. So now look here, heat transfer. What is meaning of heat transfer? So exchange of thermal energy due to the temperature difference is known as heat transfer. So heat transfer, what is exchange of thermal energy due to the heat transfer? So there are having three types of heat transfer mode, like conduction, convection, radiations. In the universe, heat transfer takes place in the three mode only: conduction, convection, and radiation. So what is conduction? So already here, without actual motion of the molecules, that I will explain what is meaning of actual motion of molecules. So see here, first one examples I will give. Suppose you are sitting in the classroom, teacher is on the dice. Teacher, they will give the chalk piece to the first student. That students, they will take the chalk piece to the just after him students. Then like this, everyone, they will pass the chalk piece, it will go to the last student. That means this is called conduction. So what is, again listen, suppose teacher is given to the chalk piece to the first students, again simultaneously he will pass this chalk piece to the one to another. So that chalk piece will reach to the last student. That process is known as conduction. Then once I will go and I will give the chalk piece to one student, again another student, again another student, will reach finally to the last student. Then finally we will throw this chalk piece to the last student. That is called conduction. And if I will go, I will give one by one student, that is called convection. So another one more examples I will give. I kept here. You see here, one pot is there. I kept on hot water. Now heat this hot water. We are heating this water, or directly you can expose this iron rod to the heater, no issue, or hot water you take. So here we have to explain this all three modes. So I taken the hot water. So this iron rod dipped in the water. So what will happen? See here, first one more examples I'll give. This is, suppose iron rod is there. Iron rod is there. In this rod, having lot of molecules will be there. Once you are heating this part, it's the handle. This part you are heating, you catch that handle. You will see after sometimes you will feel the heat. How this happens? See here, first you are heating here, near molecules will get heated. That molecules, they will not change the place. That's why I wrote without actual motion of the molecules. So molecules, they will not change the place. That molecules one will get heated, it will vibrate, it will jump, and he will transfer to the heat to the neighbor molecules. Again similar neighbor molecules will get heated. Again that neighbor molecules again will jump, and he will transfer to the neighbor molecules. Simultaneously all the molecules will get heated and full iron rod will get heated. So that is process is known as conduction. So that's why I wrote without actual motion of a molecules is known as conduction. So similarly here, first molecules will hit, then they will transfer to the energy to the another molecule. Similarly it will get heated. That is called direct contact. So this process is known as conduction. Now what is convection? Convection means change the phase. Now suppose you are heating here, in this bottom part, water molecules will get heated, and once water will get heated, this density will be less, and that water wants to go up. Then what will happen? Near base, vacuum will create. So cold water will rush to the near to the base. Again that water will get heated, again will go. So that means this molecular, what is this here? Actual motion of the molecule. So the molecule motions will start. Molecules will go up, again cold molecules will come down. So this process is known as convection. So see here, heat. One hand suppose is there. So what will you will feel? Some molecules, some heat energy. Due to the heat energy, you will feel the heat. So that process is known. Actual motion of the molecules is known as the convection. What is this here? Radiation. This is nothing but radiation. So now look one example here. One candle is there. once flame is there, once you are burning the candle, this is first position, another candle I am taking, this flame will be like this. This flame will be like this. This flame is straight, this flame is going vertical, which is possible now. Look here. If this, once you are burning the candle, this is not possible at all. Why? This possible only. Why? Because once you are burning the candle, in this part, air gets heated. In this part, air gets heated. Then this air, already told air density is lower than air density. If air will get heated, its density gets less. So that less density air, they wants to go up. They wants to go up. Then here vacuum will create. So near air will rush to the vacuum. Again that air also will get heated. Again it will go up. So finally see this. This is the actual activity it will happen. So that's why finally they will keep the flamage up. Now similar here, why I explained this. Now heat is there. Once the surrounding air will get heated, that heat energy, that air, hot air will go the up only. So heat energy will not come side. But then also you will feel heat here. Then also will feel heat here in that hand. Because some wave, electromagnetic wave will be there. So without medium, here air will not be there. Then also you will feel some heat. That process is known as radiation. So what is radiation here? Transfer of energy in the form of electromagnetic wave. Suppose sunlight will be there. Sunlight will be there. This is earth. How the heat is coming here? By the electromagnetic wave. No medium required. So no medium required is known as radiation. Direct contact without actual motion of the molecules, conduction, and actual motion of the molecules. Molecules, they will change the place, one place to this place, the circulations will be there. This process is known as convection. So this is the mode of heat transfer. Suppose one more thing. Suppose one cold water. This is cold water. This is hot water. Contact together. What will happen after some times? Heat transfer will take place. That means they will gain the heat, they will lose the heat. Finally, these two temperatures, all molecules will get heated. So suppose this temperature is the 20 degree, this is 80 degree. Finally, this approximately this will come 60 degree. We cannot say exactly, but approximately this will gain the heat, this will lose the heat. Finally, it will come the equilibrium. So that is known, this process known as heat transfer. So exchange of thermal energy due to the temperature difference is known as heat transfer. Okay, that is the basic. Now, how to derive the formula now? First, we'll discuss only conduction. Okay, so now these things I will rub it. Now look here. Fourier's law of conduction. Fourier's law of conduction. So here heat transfer will take place by the conduction itself. Heat transfer will take place by the conduction and heat itself. So one formula will be Q is equal to minus Ka dt by dx. What is this? We'll explain first this formula. So Q is heat flow. Q is nothing but heat flow. Unit will be watt meter Kelvin. How this will come, that also we can say here. Yeah. K is thermal conductivity. K is nothing but thermal. K is nothing but thermal conductivity. What is A? Area. Area of the plate. Of the plate or block. Area of the block or block or plate. dt. Temperature difference. Tt temperature difference. Dx is small elemental area. Small elemental parts, you can say. That's why I'll draw the one diagram. Suppose this is one wall is the wall. If we'll take the small strip, this thickness will be dx. The total length thickness will be L. This one side temperature will be T2. Another side temperature will be T2. See this one temperature I taken up, this down. Once one side heat will crosses or heat, if heat will crosses to the wall, temperature will decrease. Temperature will decrease. If will distance will increase, temperature will decrease. So that means this negative sign also is here. Negative sign what is? If we increase the distance, heat transfer will reduce. Temperature difference will reduce. That's why it is minus E there. So dx is nothing but a small elemental area. A small elemental distance, you write. A small elemental distance. This will be in meter, temperature in degree Kelvin, area in meter square, thermal conductivity will be, see how we'll know the thermal conductivity. Suppose you don't know. Q already you know watt meter Kelvin is equal to area. K unit I need, area meter square, temperature Kelvin, this is meter. So K unit what is? This meter cancel. So what will be the K unit? This is watt, no? Why I wrote this? Watt. This is Q unit is watt. So watt per meter Kelvin is known as thermal conductivity. This is Kelvin. So watt is the K, thermal conductivity unit is watt meter Kelvin. Watt meter Kelvin. So Q unit is watt only. Sorry. Q unit will be watt. Heat flow unit is watt only. Heat flow unit is watt. So K unit is watt meter Kelvin. Area, degree Kelvin, distance. So, okay. So K unit will be watt per meter Kelvin. Okay. So here Q unit is watt only. How I wrote, I don't know. Watt only. Okay. Now you look here. From there, how to remember this formula? How to will bring the heat flow rate for the single block, double block, then composite block. How will take? Now look here. So this part I think I will rub it. Now look here. Now I will take one plate. This distance is L. That means this place L is equal to 0, L is equal to this total length, L is equal to L. This is temperature, one side T1, another side temperature is T2. How this coming? So here write Q. Bring this dx here. We'll write here minus Ka dt. This equations number 1. I'm analyzing this. If we'll integrate both sides, so Q is heat flow, unit is watt. Integrate dx, small elemental area. This is small elemental area. To unit L is equal to 0 to L. So 0 to L will integrate. Minus Ka dt. Dt now what is? Change in temperature T1 minus T2. So dt is nothing but change in temperature. So final temperature minus initial temperature. So this will be T2 by T1. Now if we will integrate this, what will come? Qx 0 to L is equal to minus, always will be there, minus Ka T1 to T2. It's not clear? Then you write here itself. Qx 0 to L minus Ka T1 minus T2. Now look here, what will come? Q, already you know, suppose A and B, fx is a function, then how will apply the limit? Upper limit minus lower limit. Like this we have to write. Upper limit minus lower limit. So here x. So what will come here? L minus 0. Upper limit L minus 0. Now minus Ka. What will write here? Minus Ka. Temperature T2 minus T1. Upper limit minus lower limit. So what will be there here? QL is equal to, if this I am writing, if we remove the minus, what will write here? Ka T1 minus T2. Lower temperature. If lower temperature minus maximum temperature will take, the negative will come. So negative negative will get positive. So now I am writing T1 minus T2. So this will come K as T1 minus T2. Now that implies Q is equal to Ka T1 minus T2 by L. This came heat flow formula. Heat flow formula is K T1 minus T2 by L. Okay. Now you look here. From there, we'll design now how we'll write the formula and all. So I'll come up. So these things not required. Come here this side. So now look here. Ka came now. Now Q is equal to T1 minus T2. That is called overall temperature difference. Because one block is there here. Block number 1, wall, single wall. Overall temperature T1 minus T2. Bring this Ka down. L by Ka. L is distance between one end to the other end. K is thermal conductivity, edge area. This you can write T1 minus T2 by thermal resistance. What is thermal resistance here? L by Ka. This is the very important part for this heat transfer problem. So for conduction thermal resistance, now this we taken for the plain wall. If we take the cylinder, if we take the spherical part, so this everyone having thermal resistance. If you understand this thermal resistance, now see how simple this formula we can write. So this thermal resistance, overall temperature thermal resistance, heat transfer will be the single wall. This formula came for the heat transfer for the single wall. So what formula you got now? If they will give the temperature T1, T2, length they will give. They will ask find the heat flow. You can find out thermal resistance first. What is L by K? K is thermal conductivity. Area they given. So you will find the heat flow rate for single wall. Now similarly, you come this side now. This notations and all not required now. I will rub it this all part. Now what I am going to do here? Single wall formula is this. Now you take the 2 or 3 wall. Suppose first I am taking 2 wall. 1 and 2. So I am taking 2 walls, 1 and 2. Its thermal conductivity is K1, this thermal conductivity is K2. This temperature is T1, this temperature is T2, outer temperature is T3. So, okay, I taken 2 wall. This length they given L1 and L2. This length given L1 and L2. Now how will write the formula? If you know the first formula, first wall, what is? Q is equal to overall temperature that I told. What did I told? Overall temperature. Here what is overall temperature? T1 minus T3. Or if you write here T1 minus T2 by L1 by K1A, if you will add, so this final temperature what will come? Overall T1 minus T3 only. So overall temperature will come T1 minus T3. What is T2? Interface temperature. Now here T2 is nothing but interface temperature. T2 is interface temperature. Now I am taking 2 wall, then I will take 3 wall, 4 wall. So how we will write the formula? See, this formula and all is there in the data book also. But if you will see this nature, if you will see this design of this formula, then you can identify, oh, this formula for this wall. So, okay. So what is the formula here? 2 wall is there. For first one, what is? L1 by K1A. This is called first thermal resistance. L2 by K2A2. L2 by little bigger. L1 by K1A plus L2 by K2A. What is this one? Heat flow for the second wall. So first wall what you saw? Suppose again you see here, this is first wall. If you will write the thermal electrical circuit, this is the point. What is this one? L1 by K1A. This is what is L2 by K2A. If this single is there, what is thermal resistance? L by Ka. This is called thermal resistance. This is called thermal resistance. So here little I will write little bigger. So thermal resistance, what is? L1 by, you can write here R thermal 1, R thermal 2. Thermal resistance of first wall, thermal resistance second wall. This nothing but L1 by K1A. This nothing but L2 by K2A. For single wall, you are saying for double wall, wall 1, wall 2, this is the formula. What is the formula for the heat flow? Overall temperature difference by thermal resistance 1, thermal resistance 2. Directly write L1 by K plus L2 by K2A. Now, similarly, here itself I will do now. This remove here. Now here itself, I will increase one more wall. This is called K3. Thermal resistance will be R thermal 3, L3 by K3A. So what will be changes here? Here will be changes L3 by K3A. What will be changes here? Overall temperature. Overall temperature, what will write here? T3 minus T4. So if single wall, you know how this formula coming, you know. Increase the wall. This one questions always will be there like this question. Increase the 2 wall, 3 wall, and insulating and all either that later on will do. So first simple concept what is, if increase the wall formula, this you will increase overall temperature by this. Overall temperature by this only. Okay. Now this is the one part. Now if same conduction problem, they connecting the convections also. So what will happen, that you see here. Another part what is there here. If 3 wall is there, suppose assume the 3 wall. Assuming the 3 wall, both conductivity will be different. L1, L2, L3. Temperature will be T1, T2, T3, T4. These are the temperature for inner surface, outer surface. Suppose here conductions, already this formula will be there, heat flow. If inner wall also having convections part, if inner wall having convections like hot air, hot water, oil film, like this. So this temperature is suppose TA and heat convections will be HA, convective heat transfer. Here will be the TB and HB. So what is H? Before this you should write here Newton's cooling law of heat conductions. Newton's law of cooling. What is this one? HA. Heat flow is equal to HA TT. So write T1 minus T2 because DT not T1 minus T2. So okay, now see here T1 minus T2, right? R surface temperature R, that you write here some surface temperature. T1 T2 middle is there now. Surface temperature and infinity. So where TS is nothing but surface temperature of the surface. Surface temperature. T infinity fluid temperature. T infinity will be the fluid temperature. Fluid temperature. H is heat transfer coefficient. Heat transfer coefficient. What is unit of the heat transfer coefficient? See here, Q unit is watt, H I need, this is meter square Kelvin. So heat transfer unit is watt meter square Kelvin. Heat transfer unit is watt meter square Kelvin. So suppose in this given plane wall, if conduction and convection both will be there, what will be the formula changes? This formula here itself I will connect now. Here itself will connect. So what is the thermal resistance? If you draw the circuit diagram, circuit of the thermal resistance. See here, draw one line, draw this here. Here one circuit, here one circuit, here one circuit, here. So now see here. Here, what is thermal resistance here? Newton's law of cooling. Now I will repeat this Newton's law of cooling. Now see what is thermal resistance here? 1 by HA. HA, yeah? HA into A. What is L1 K1A, L2 K2A, L3 K3A, then 1 by HB, then A area. So what is the formula for the heat flow? See here, heat flow is equal to what will be changed? What is overall temperature there? TA minus TB. So overall temperature, what will be changed here? TA minus TB. So overall temperature change. What is the total resistance? 1 by HA into 1 by HA into A plus 1 by HB into A. This is the formula. So this all formula is there in the data book, but you should know the at least face of this formula, so you can identify, you can find out, you can see this formula and you can identify, oh, this formula is for this problem. So what we saw in our heat flow rate here, heat flow, overall temperature, TA minus TB, total thermal resistance. What is this one? This is nothing but total thermal resistance. This is known as total thermal resistance. So based on this, 3 or 4 problem will be there. So out of these 2 or 3 problems will come in your exam. Now here again we'll modify this. So where we'll modify, look here. Problem will solve in the next video. First today up to this. Now one more step is the overall heat transfer coefficient. How we'll find? Using nothing but overall heat transfer coefficient. Overall heat transfer coefficient. What is? Q is equal to UA, overall temperature. Suppose TA minus TB is equal to, this we have to write here. Again this also Q now. So what we write here? TA minus TB. What is overall heat transfer coefficient here? 1 by HA into A plus L1 by K1A plus L2 by K2A plus L3 by K3A plus 1 by HB into A. How to get the overall temperature? Both are Q. So heat flow rate will be same. So this and this got cancelled. Suppose A you take top. If you are taking A here, so A should not write here. A will go numerator, so remove the A here now. Remove the A here. Then A also will get cancelled. So this Q, this also Q, and this also Q. So both LHS is equal, then RHS will be equal. No? So what is U equal to then? What is U equal to? Remaining part is overall heat transfer coefficient. So this way if you remember, you can. So U is equal to, what is formula for the overall heat transfer coefficient? HA plus N1 by K1 plus L2 by K2 plus L3 by K3 plus 1 by HB. So what is this one? Overall heat transfer coefficient. What is this one? Overall heat transfer coefficient. Its unit is also nothing but watt meter square Kelvin. So overall heat transfer is watt meter square Kelvin. So this unit is watt per meter square Kelvin. This unit is watt meter square Kelvin. So how to find the overall heat transfer coefficient? This is the heat transfer for the conduction and convection. If you want overall heat transfer coefficient, or they will ask, what is the overall heat transfer coefficient? This is the formula. What is the total thermal resistance? If they will ask, what is the total thermal resistance for this? So this is the total thermal resistance. This part is known as total thermal resistance of this given diagram. Now if they will ask interface temperature, so how we will find the interface temperature? Last part for this derivation, interface temperature. So look here, interface temperature, I will write here itself. So interface temperature, what is? So overall temperature you are seeing now. This actually, if we split this, what we can write? I will show this. TA minus T1. What will write here? 1 by HA into A. Second, what we can write? T1 minus T2. What will write here? L1 by K1A. Like this will write, no? If all the add together, we'll get this only. We'll get this only. So if we are separately writing, it will look complicated. So this plus this, and then all you will write, you will get the final heat flow. Then how will find the interface temperature? So T1, T2, T3, T4 are the here interface temperature. So look here, this itself a Q, this itself a Q, this itself a Q. Then another what is T2 minus T3 by L2 by K2A, itself Q. Then similar this also. So we'll take first this one. If you want interface temperature, that means there are T1, T2, T3, T4 are interface temperature. Q you can find out from this formula. Q you can find out this formula. Heat transfer coefficient you will know. Area you will know. TA you know. TA you will know. T1 we can find out. Once you got T1, again you write again Q is equal to T1 minus T2 by L1 by K1A. T1 you know. Q you know. L1 distance you know. Thermal conductivity you know. Area you know. You can get the T2 from here. Similarly again T2 by T3, you will get T3 here. Again one more formula you write. What is this one? T4. Write that also. T3 minus T4 by 1 by HB into A. So from there you will get T3. From here you will get T4. So that way we can get the interface temperature. Interface temperature for all. So if you know this concept, if you know the derivations concept, whatever questions will come in this range, collect the data, substitute in this formula. This way you can analyze the formula and you can solve these questions. Okay students, what you do, revise this full formula once and twice. Next video what will give? Next video I will solve the 3 to 4 problems based on this part only. So without revision, without twice revision, you will not understand, because heat transfer subject is a very big, very vast. But if you study like this, what I am giving first video, then second video I will go only plain wall only. Will not go now cylinder and sphere. Again cylinder like this formula will analyze. How to write the formula, that also I will tell you. From the conduction itself, will go to cylinder with area will be 2 pi RL. Substitute that area, you will get the thermal resistance. Again we will go the sphere, pi A is equal to pi r square. So that way only 4 pi r square. So that way only we can find the formula. Thermal resistance will find everyone and will correlate this and will get. So first your work is this video, revise twice, copy down the notes, then be ready for the next video. So I will solve the questions itself. Okay. Thank you students. Subscribe the channel. Okay.